Hello and welcome to another Blender Sushi tutorial. I'm doing another live noding, and this time we'll be talking about how we could modify the vertices of mesh. So this is probably something that's slightly more intermediate level kind of tutorial, but still I'll be discussing like the basic foundation of it. So that everyone can follow, even though if you're just starting to use animation nodes. So starting from this scene, like when you open Blender, it's in the default layout. We're gonna switch to compositing layout, like usual. Um, okay, in the scenes we just have the cube, but this time we're gonna use a grid. Let's delete the default cube. Now I'll just create a mesh grid, and it's a really tiny grid. I'll just scale it slightly, like 5 times. I'll hide the lamp and the camera, put it in layer 2. Right, and let's switch to animation node, add on, and create a node tree. As usual, we're gonna source our original object. Since we will be dealing with the vertices and stuff, we will use the mesh data node. Let's check mesh data, and let's grab that object. And then vertex locations. Okay, we're gonna be using loop because we want to modify each and every vertices. There is like a hotkey you can use. It's W. If you're holding a node and you click and you tap on W, you can loop through things like vertex locations, edge indices. Let's say, okay, we're gonna be dealing with a vertex, but we will be using the vertices because the vertices will give you attributes like the normal and the positions, not just the positions. We'll have a look. Okay, so it's automatically creating the invoke subprograms and the loop input for you. We have our vertex ready to be modified. Before we start anything, let's make sure we have the input and actually the output as well, not just something like this. We don't know what's going on there. The output itself is going to be vector data. It's a vector list, and we're going to pipe in. Now, see, you can't just pipe in the vertex into the vector because vertex contains. Sometimes we can kind of interchangeably pipe in the vertex and vector and vertices or whatnot, but generally they are like the same kind of data type. They have 3 different values inside them. But anyway, with vertex, you want to use vertex info node, and by using this node, you can get more information, kind of like the location of each vertices, the normal of the vertices. What is the normal? The normal is probably, I don't know how to explain it, but it's kind of something that's pointing out from, if it's face normal, you know, the normal of a face is the face that's pointing at the screen, while vertex normal is similar to that. basically if you go to an edit mode, and let's see if you can go and find a normal mesh display the normal. So that's the face normal. You have the front face and the back face, and you also have the vertex normal and vertex per face normals. Yeah, that's actually the normal of the vertex. That's that thing over there. And you have the group weight. That's probably the weight of the vertices. We might touch that at some point. Anyway, we just gonna worry about location and normal for now. Location and normal. With the normal, you can push a point in the direction of the normal, basically. So let's have a look. Let's try. Let's use a vector math for now. We're gonna push the position of the normal. We're gonna push the position of the vertices. Push it by the normal. And output it. So that's our little subprogram right there. And this is our data. Let's output the mass by using combine mass data. Pipe in the vector list, while the edge indices and polygons indices are the same. We just plug it in like that. The hard job will be like over there. The computer animation nodes will do all the calculations. And then let's have a look at the output. Mesh data object out. Mesh object output. That's what we want. Let's plug in the mesh data. Turn it on. And create a new target object. Like that. So let's turn on display all wire. As you can see, it actually moves like one unit. Following the normal, basically. We can use vector math to multiply the number. Vector math. It's gonna be adding the vector. Let's see. Multiply. We want multiply and pipe the normal. And plug this back in. Right, so now we can, you see, we have control of how much displacement we want to do. This can actually be just a single value. Oh, it's actually the Z. But normally you can also use value, vector from value. Just plug in like that, and you have that happening. So that's if you have a grid. Let's save this for now really quick. With the grid, it's probably not so clear. If you have let's see, mesh like a torus, for example. Let's see, it's our torus, and let's grab the torus, and now you can see how our mesh, with our mesh objects, we're kind of pushing in and out like that. That's because we are using the normal. Same thing if you have if you use the monkey head Suzanne, we will have the same effect. Delete the torus, select Suzanne, grab Suzanne, and oops. Okay. We lost the target, our target mesh data. Let's take it. Let's create another one. Okay, so that's our result right there. Push the vertex and pull the vertex in, or push it out. So we have something like that, which is really cool. I kind of want to point you out something though, like as you might already notice, whenever we work with animation nodes, oftentimes we create a new objects that's to show the display. You probably ever wonder, like, what if we want the original and then do all kind of things inside animation nodes and actually piping in the data back into the original, and we don't want to have additional objects like that. So it's kind of behaving more like a modifier, Blender own modifier. It's kind of like the displays modifier right there. Yeah, you can actually do that using animation nodes. Sometimes you might have like a suppressing behavior, but if you're really careful, you can actually pipe in the data back into the original mesh. So the way to do that, I tried this, and this is probably the best you can the best way to do it. So instead of so that's the original Suzanne, right? And that's actually the target mesh. If we bring in the outliner, have a look. Oops. That's actually the target, and that's the original Suzanne. With the target, oops, delete keyframe. So see the effect is happening on the target. We actually want to pipe it back into the original. So how are we going to do that? Let's save first. So what we have here is object mesh data, right? What I will do, instead of sourcing original Suzanne and piping it back to Suzanne, what's gonna happen is the mesh will explode, and you don't want that. It's causing like infinite loops. You don't want to do that. What you want to do is to bring in Suzanne as an object input right there. Let's grab original Suzanne, and with the object mesh data right here, we're gonna, let's see, make sure I'm doing it right. Okay, we're gonna actually make a copy first, object instancer. Here, I'm gonna turn on copy full objects and dip copy. We're gonna create just one copy of the original object, pipe in the original object. So what's happening, you see, we have the copy of Suzanne right there, and we have original Suzanne. And now with this copy, we will pipe it into the object mesh data node like that. And since we have the copy of full object, including a copy of the deep copy of the mesh data, we can now pipe in the original Suzanne into the final mesh object output. So let's see if this is correct. So that's, we don't need this. That's the original Suzanne. Okay, now we have this kind of behavior, kind of like double transform. I believe if you switch off the use workspace, yeah, it's kind of correct, and then put Suzanne back into the center. Whoops. Let's just delete this. Let's create another Suzanne. Let's grab original Suzanne. So that's going to be the copy. That's the original Suzanne. The original need to be, that should be off. Okay. And that's actually the data we work on. It's kind of like the ghost data. We don't need to look at it. We can hide it and make sure it's not selectable. And that's the original Suzanne. See, now the original Suzanne is getting the result of data instead of like a new object. So that's actually what you want. And let's move it back to the center. Let's see. Alt G. Yep, Alt G. Original Suzanne, and we can do that now. It's really cool actually. Normally you don't have access to all this quite that easily, but now you see with animation nodes you can do that. It's kind of really simple. The logic behind it is not that complex at all. The math can be complicated, but the logic is super simple. So what you have is, you have original Suzanne, and you make a copy, like a ghost copy or something, and then you edit the ghost copy, the data, and you process it right there. What we do is just from the original, for each of every vertices from original locations, push the vertices in and out based on the normal, and pipe it back outside. If you ever work on using other 3D software like Houdini, Houdini has something like this as well. And normally you kind of you can work on the the base level, the object level, and you can go inside the component level, and you work on the component data, and you go back up right there, and this part right here will be hidden inside this. So it's kind of really powerful. It feels intimidating at first, but then again you have a lot of power to do all the complex thing like that. So let's should we work on Suzanne? Maybe let's use a simpler objects like a torus, and then reset the position. We don't need the grid for now. I think, yep, we don't need the grid. We're gonna delete Suzanne. Let's get our torus. We have our torus. Let's see if it's still working. Yes, it's still working. We don't need to see the ghost. Hide the ghost. And that's the original torus. and let's reset it to 0. What I want to do next is to show you just using vector wiggle and random vector nodes how we can disturb the vertices, and then after that I will switch into something that's more little bit more complex, because we're gonna use expression, and we will be using Mathutils module from Blender itself, and it's kind of like scripting, but not really. It's more like using expression, because everything here is already set up for you inside Blender. Okay, so we have our donuts torus there, and we have our vertex going into vertex info. Don't worry about all this for now. Let's use things like random vector, plug in the index into the seed parameter. This will output random vector value, as you might know. So it's gonna push the vertices in all directions randomly. And let's try. See, you get something like that. 10-15 years ago, to do something like this it's kind of really cool when I first make a mesh like this. These days it's not so cool anymore. I mean, yeah, you can get like an interesting render out of it, but yeah, that's random. Random is cool, but it's not really interesting. The vector wiggle is more interesting, and if you get into this kind of thing like noise, cell, fractal, turbulence kind of functions, you'll get a much more interesting result. Let's have a look. Just gonna hide that part. I don't really need to look at that. Let's save this for now, just in case it crashes. File, save as. Okay, random is cool. You might use it sometimes to give a little bit of variations, but not too much. Noise is actually more natural. Wiggle is kind of, like I said before, vector wiggle is like a noise. It's kind of like a wave pattern, but a little bit more advanced than a normal noise, maybe. Okay, vector wiggle. Okay, let's see. With this index goes into the seed. Evolutions is gonna be a frame. Always like this. Let's create our playback timeline over there. Plug in the vector. Oop. Okay, it exploded. It's alright. That's because the amplitude is a bit high. 0.20. Let's have. Okay, I plug in to the wrong parameter. With the time plugged into the evolutions, we will have something that's kind of wiggling. It doesn't need to wiggle too much, like 0.05 probably is enough. And you can play back. Increase the speed like 5. So it's wiggling. My MacBook Pro is a bit slow because it's I don't have much graphic card power on this computer, but it's still doing it you don't need to worry too much if it's when you're working procedurally and it's kind of slow. Don't worry, because that's normal, and you probably gonna cache or bake the result anyway, kind of like baking it out as in Blender you have MDD point cache. If you bake it out and bring in the cache back, it's gonna be fast and playing back in real time. So that's that's kind of some important information for you right there. So wiggle, of course, is doing a wiggle, and we are doing it on the original mesh, as you might have seen. There is something though, like if we have this setup, and let's say I create another object like a cube, and then let's subdivide it real quick. Subdivide it again. Now let's look at this object. This is our original torus, right? And that's the new cube right there. What happened if I just grab the cube? The cube, okay, let's hide the ghost of the cube. Now the cube is wiggling, but you see our original torus, it's becoming like this. It's messed up. I kind of don't like this kind of behavior. I like it more like a modifier. If you have, let's say with Blender own modifier, if you have a plane and let's turn on, let's bring this back in, let's subdivide this. Oh wait, let's turn on the wireframe. Wire, draw all edges. Why is it not displaying? Okay, don't worry. Let's subdivide. Subdivision. Increase the subdivision. We don't want it to be Cadmiel Clark. Let's keep it simple. Increase it 4 times. Okay, we have something like this. And we have, if we use like a Blender own Vertex pusher, which is the displace modifier. Okay, we can displace it like that. But normally the cool part is when you push it using a texture. That's the part that I think eventually we can do inside animation nodes. I don't think we can sample texture map inside animation nodes yet. You might be able to do that using the script node probably, but it needs to be a node, and let's just wait on that. But if you use, I mean, what I want to show is if we are using Blender's own modifier instead of making our own displace modifier, like if we are using Blender's own, and we can use textures. So let's create a new texture and let's jump into the texture. Let's see, what do we have? Displace, image. We don't want image. Let's see things like cloud. So it's displacing our mesh base using this texture. It can also be things like noise is not so cool. Sticky ocean. Voronoi is cool. See, if we can always, with our Blender modifier, stack modifier like this, we can go back and increase the resolution and then back to the texture. Maybe we have too much strength there. Let's reduce it. So we have something like that. Let's get rid of the wire now. We can continue increasing the resolution. Okay, maybe that's the maximum for that. Maybe just make it 4 and then create another subdivision, put it up there, increase it. Okay, that's detailed enough. You can see the for noise happening right there. So we kind of like that. Just imagine what was our original mesh. It was just a flat. So if we say, oh, okay, I actually don't want that anymore, if we delete the modifier, it goes back to original. That's I like that kind of behavior more than that's something like this. So what was that? Our original was the torus. Why is it all meshed up like this? So in order to prevent that, I kind of want to propose something like, let's make another torus, something like this. So you have the original torus. Let's source that torus. It's displaced now. Hide the ghost. It's displaced, but we want to create something like a toggle, so we can always go back to the original before we turn it into like this. We can use switch for that. Switch, and it's gonna be like this. If condition is true, if the condition is true, pipe in the process vector. If it's false, just use the original vertex locations and pipe that in like that. Let's try on, off, on, off. So now if we if we like this kind of effect and we want to apply it to another object, like, okay, let's try like a sphere, for example. That's the original sphere. Before we switch to the sphere, we just turn off the effect first. So that's the original torus. Let's source the sphere and turn on the effect. So, and turn off the ghost object. We don't want to see the ghost object. So yeah, that's kind of a better behavior, right? Let's bring back the timeline. Let's hide this one. So that's cool. Wiggle. You can actually mix the wiggle with the vector as well before you adding it into the original location. Let's see if that's give a better looking effect. There are two things. You can use mix vector, so kind of giving like half of the effects. Normal, so normal, pass it in, vector, pipe in the result in there. So 50-50, it's a blend between the two. We probably need to multiply the normal as well right there, but a lot of cool things you can do with normal and vector, and you probably need, if you're not like super mathematic, if you're not super expert in math, you probably need to Google for things like that, how to multiply the vector and how to get, for example, how to get a vector to look at a certain point, or how to modify a vector in a certain way. You will probably need to source Google for that, but I'm just showing you what we can do with it. You can use all kind of vector math and things like cross product. Yeah, all this, play around and try to mix vector and see what kind of output you get. Now, before, let's save this. One more thing I will want to show you is this thing that looks really scary. And if you're Blender developers, you will probably use this a lot, and you will be typing the code in Python. You're kind of doing that as well with animation nodes. You can do that. It's kind of more, really, it's more artist friendly. You don't need to be like a super high level programmers to deal with all kind of scary functions like this. I will show you how you can use this function right now. So instead of using the location and the normal, instead of using vector wiggle or random vector, we're gonna write our own functions using Python. It's not as scary as you might think. We can actually start by using a simple function. Let's try like a sine function. Let's hide this, delete. Okay, good. It didn't crash. Create a mesh, grid, delete everything else. Let's center the grid. Alt G will reset the objects into center. Okay, let's source the grid. Hide the ghost object. The ghost object actually will save the original vertex position. It's kind of our reset positions, which is cool. And so we have our location, and then we have vector math, and let's see. You know how sine wave will make like a kind of like a wave kind of motion. It gives you a value that goes from 0 to 1 to -1, and it's kind of interpolating in a smooth kind of way. And if we apply that into our vertices, it will give you exactly that. So let's have a look. Grease pencil, delete, grease pencil, hide this. We don't need this. Sine function, math. There's a node that does that. Math, sine wave. Let's see, if we want the sine wave to go up and down in the z-axis, but then the value that travels is, we can use the x value of each vertices for that. Let's turn on the wire. So at the moment the z is all 0 and the grid is flat, but the x and the y, we can use the x and the y value and pipe it into the sine, so we have like a wave, right? If you don't believe me, I will just show you. Locations, okay, vertex. Let's separate the vector. Separate vector. Plug in the vector. Now it's separated. You can actually debug this, but you need to use debug loop. Debug loop. Plug that in. Have a look inside. See, and you can see the vertex number. If you turn on the line, the x values is traveling in 3D space, and it's giving you all these numbers. It's all in order like that, while the z is actually, the z is 0, 0, 0. Yep. So you can use the x or the y. Just pipe it into our sine, and as a result, you'll get a value that goes from -1, from 0 to 1 to -1, back to 0, kind of like a wave pattern. And we pipe it in back into our vertices position. Let's combine it. Combine vector. Cool. Combine vector. I did this a lot in, I wrote a lot about this as well in my blog. And what just happened, I plug in the result into the x, which is wrong. That's really wrong. It should goes into the z, while the x and y is the same. So now, believe it or not, that should be like a sine wave happening. Save this. If we push, let's see, if we offset the value of the x, it's gonna give you a sine wave. Let's prove it. Create a math. Use an add will offset. Result piping. So, oh, actually, that's moving that thing. The result should go in there. Now we have a sine wave. Oh, wait a minute. What did I do wrong? Oh, okay. That's cool. Didn't expect that. The x should be the original value, right? So because you want it to stay. But that was a really cool effect. I didn't expect that. You have the wave. Now you can do your math formula right here, like using multiply, make the sine frequency goes faster, make the amplitude goes like a bigger wave or smaller wave. You can do that using nodes, but it's much better if you actually use a formula expression. You can use either the expression node or you can use the script node. You probably will want to use script node eventually, because it's much easier to edit with script node. Let's see how if you want to use a quick one, like we're gonna use expression node. So instead of having a sine formula using nodes, we will use expression. Let's hope that this works. Okay, expression. It's gonna be in the middle here. Let's see. The input, our input is gonna be float. Float data value is gonna be, yes, the x. The result will goes into the z. That's the x. We're gonna have our frequency parameter. Let's name it frequency, and amplitude, which is a float. Amplitude And one more thing is the offset as well. The offset is going to be, normally it's going to be frame going in, so we don't need the math node anymore. We have the data coming in from the X, which is the position of the X. It's going to go inside the expression, and the expression is going to be the calculating everything and giving us an output. Okay, let's see. This expression node is actually automatically calling a math module. It's a Python math module to do all kind of calculations, and you can use the sine wave inside math module. Blender has its own module, Mathutils, that we can use later. For now, we're gonna use this. So the math module is already imported, and you can use it in the expression. So it's gonna be as simple as typing math.sine, and it's gonna be x plus the offset, I believe, times the amp, and this is gonna be times the frequency. Enter. Let's zoom in. A sine of frequency times x plus the offset times the amplitude. Okay, let's check it out. We need some float. Frequency, let's see, 2, amplitude 2, offset. The offset is going to be time. See, it's already happening, right? Yay, it's working. Time info node, frame goes in there. We can adjust the frequency. Okay, keep the frequency, adjust the amplitude, and let's check it out. Yep, it's working. So yeah, that's if you wanna use expression, you can type in whatever expression there, and it can be as complex or as simple as you want. Sine is the simplest, I guess. It can be just like an add or multiply as well. But like I said, you might want to use script node instead of using expression. Here, like this, compared to script node. With script node, you can have more control over the output really easily. So you can have multiple result output and multiple inputs right here. It might seem complex at first, but in the long run, you want to use script node. Yeah, just remember that. I'll just show you how we can use this formula right now. Oops, okay, did something there. So let's see. So Mathutils is a module that's built inside Blender. Apart from the BPY module, you have the Mathutils module. It has a lot of cool stuff in it. I think even the BVH is inside Mathutils. For now, we don't really worry about all that. We like to use this mathutil.noise, and we're gonna use it inside animation nodes. So, and let's see, you pick which one you want to use: cell, self, vector, fractal, heteroterrain. What is that? Hybrid. multifractal noise vector random. It has its own random turbulence. I think turbulence is really cool, but for now just use simple fractal. Just imagine all of this. There should be a node inside animation nodes, but at the moment we don't have this noise node. Eventually the developer will create it, hopefully, fingers crossed. But for now we can use these functions as a node inside animation nodes by using the script node. And all you need to watch out is the parameters. That's going to be the inputs data and the return type. See, if you see the float, it's going to be, the output is going to be float. It's going to return, see, the cell noise value. This is really useful as a documentation to show you what the function does. It's kind of like the sine. With the sine function, you know what the sine does. With this guy, it's a bit hard to explain, but easier to see. For what we are doing, I guess we just need this guy here, right here. We might be able to check the cell vector as well. That will output the vector data. But for now, let's check this one. This guy will output float, right? Just a simple float, one single value for each vector position that you input it. So cell fractal. Wait, it's not the cell, but it's the fractal. With the fractal, you're gonna need 1, 2, 3, 4, 5 inputs, and it's gonna output the float. So this is the one that we're gonna use. Okay. Switch back to Blender. Get rid of our expression nodes. Delete, 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 delete. Script. Okay, script node, combine factor. Okay, this is gonna be our fractal node. It's gonna output a float. This is gonna be return. The input is gonna be, let's see, 1, 2, 3, 4, 5. Vector, float, integer. Vector, float, integer. We're gonna name it later. So, but we just need a vector, float, integer, and another integer, cool, vector, float with the vector. Okay. Yep. Let's create a text, and let's put the text right there. It's empty. With script node, you gotta specify which model you want to use. So you can use like import math, like the expression nodes, just like the expression, what the expression node does by default. But you can also use the Blender Mathutils module. Because it's Python, we want to see color. Import Mathutils, and then just copy and paste this function. Let's hope this actually works. It's a vector A, B, C, D. That's our script. Okay, should I leave it like that, or Let's just name it position, age, lacunarity, position, vector, age, lacunarity. Let's use lacunarity, octaves, and noise basis. Noise basis. The formula is almost correct. We just need to clean it up. Noise basis, noise type, integer, octaves, lacunarity, age, and position. Position, enter. Alright, now script. We just need to load our script, our fractal node. Name return is not defined, of course, because I forgot to return it. Return a good type. Let's just use a lowercase, syntax error, lie. Okay, lie. What is this? Blah. That must be a bug. Anyway, blah. It's gonna be our return. It's gonna return our fractal noise. And let's see what happens if we pipe into the Z. Oops. Okay, nothing happened. Let's collapse our script and pipe in the location of each vertices. Let's have some value, age, lacunarity, octave. Oops, noise basis. So this is our script node. This is the info subprogram. This is the actual node. This is the script that does the creation of the node, and we get the function from here, from Mathutils. You see how that's the only thing that's we need to type into the code, right? Normally you will need to type a lot more, and you have something like this. This is really cool and useful. In fact, if you have let's say you can play around with the number, lacunarity doesn't give much. The age didn't give much either. Maybe I did something wrong, but if you use vector math, and slide the X or slide the Y, get something like that, which is super cool. So now you have the fractal node inside animation nodes, and you don't need to see at the script anymore. You can hide this. So from our original mesh, and see how it's duplicated into this ghost object, and then we pipe it into that thingy, and we have our script, the switch node still working. So yeah, so that's pretty much what I want to show you. You can do a lot with this, and I guess, yeah, just give it a try. Like, try each one of these functions. Let's see if you can have different effects. For example, heteroterrain, fractal. I thought we have like a fractal vector or something. Maybe we don't have. But try all these functions and make your own custom noise node like that, folks, and see what's the output you get. Actually, yeah, if you can understand all this, it's gonna be so useful with a lot of things that you might need to do all kind of effects. Actually, yeah, so you just basically recreate a displacement modifier, although we don't have access to the image texture mapping yet. I wish we have that node at some point with animation nodes, but we have all this control. Oh yeah, one more thing I have to show you. This is something that I kind of mentioned it to the animation nodes developers. So I don't like how we can't smooth the mesh. There is a smooth node right here, but I think, I don't know, maybe it's a bug or something. It's giving this black kind of weird surfaces. If I duplicate it and I go to edit mode and back, it's kind of fixing it, but then you have something that looks like a double face or double edge like that. Yeah, it's something weird. Maybe it's just a Blender bug, or it's like just a small glitch. Watch out for this. I mean, this guy will still render. Yeah, I think it will still render without any problem. Let's check it out. Render. No, I lied. Did I lie? Blender cycles. Let's create a new material for this guy and this guy. Can't see anything. Yeah, I don't like that. Material. Okay. Render. It works on that object. Ambient occlusion. Yeah, I think something going on with from that object combine mesh back into here. I think I might have missed something here, but it might also be animation nodes bug that's causing it. It's kind of as if the normal is 0. In here, the normal is fixed. In there, it's failing. So just watch out for that. Otherwise, yeah, that's all I'm trying to show you today. And let's see. Yep, everything works. Play around with this thing. With that as well. All different kind of noise types. I think some noise actually give more effects with that. No, nothing. Edge linearity, maybe octave. But I like this wave effects. Yeah, so even if you have like torus, you can easily source the torus, hide the ghost object, and we have that happening. You can just use a time info node frame time info node, plug it into X. Let's play back. slow but sure. You see, it's happening. And I believe since this is our original objects, we can just use subdivision. It might crash. No, it didn't crash. Cool. And everything still works. So that's the procedural way to create your own more flexible displace modifier. Actually, you can use both on top of each other, kind of they work together, and yeah, just give it a try and play around. If you have any question, just let me know in the comments. You can YouTube comments at the YouTube channel or at the Blender Sushi blog. I will probably create an article that summarizes all this when I have time. That's all. Hope you like this kind of long 1 hour live noding video tutorial.